Welcome, I'm Bill Wake. We're here working on a new programming language called 10th. It's really just a demo language. We're trying to work in assembly language and work on a threaded language interpreter implementation. And this is just a convenient way to do it. It's a little bit of an imitation of Forth, but I'm not too restricted on words and such. Okay. We left off we're trying to do the headers and the code for one routine, and we kind of got it, but not quite. Let me share a little bit first, some pictures. Okay, so we have the notion of primary and secondary routines. So a primary routine is basically a primitive. It's a block of code that's just machine code or assembly code that we're going to call directly. And like system level routines would often be primaries in our system. And so that's the code on the left. The first, 2 bytes for him is the address of that code pointing, to 2 bytes later, and then the code itself. And then at the end, it ends with a call to the next, a routine called next. And in there, that's kind of like the return address he has to call. The secondaries are built out of primaries and secondaries, so it's a recursive kind of notion. It builds a tree. Instead of pointing to the code address directly, it points to colon, which is his routine to start a secondary running, and colon is going to keep a counter, and execute the first WA number 1 there is the address of either machine code or another secondary, and it's going to address that, or it's going to call that routine, call the second, call the third, all the way to the end. And the end is always a routine called semi, which is the basically it's a return kind of thing, returns back. So whatever called this secondary gets control again. Okay, so I mean it's some sort of return, but it's it's in a routine, so we can call it. All right, and I'm going to do something very similar. And I think this is kind of where we sort of are. We're going to create a header that's the name of the routine, a link to the previous dictionary entry. So this is maintained in a single linked list dictionary, and so you'll have a pointer to the starting, the name of the routine for the previous entry, and then the address of the code, like his example, and then the code itself, and then finally it ends with ret, which is the normal return. I don't know if I think we'll be able to do a return through the link register, just completely like a normal assembly routine. So on the in the blue there on the side, the address of code that points to the code block, this is what the compiler, we haven't touched that at all yet, but when it's building up programs with the secondary, that's the address it's going to put in the secondary that's calling this code. And then the actual address is the address of the starting point of the code, not the address of that pointer. Okay, and then the secondaries are very similar. Their header's the same. It's the name of the routine, a link to the previous dictionary entry, and then instead of pointing to itself, this points to a standard routine. I'm calling it start 2D for start secondary, and the start secondary is going to be the thing that walks through the list of addresses, and each one of those addresses points off to another block of code, or even this one if it was recursive, I suppose. And then the last one is going to be a pointer to a method, or I guess we can call them methods or routines. It's going to be a pointer to a routine that's the end secondary. Now, I sketched out something on the right. I think it's got some holes, small as it is. But basically, I think start2D, from when you run start2D to when you run end2D, that's one procedure that gets called. So it's going to have to do the save, the LR, and the VPC, because this routine might be called recursively, and it's certainly calling other routines. So, routines that call routines need to save the link register. And then I'm also imagining a virtual program counter that's going to be the current address in the list of addresses. And so when this is running, we'll have to initialize VPC to the first address. So that's kind of the first little hole between the save and the BL. We'll have to start VPC at the address of the block, the list of addresses. And then we're going to do a branch. We're going to branch indirectly to whatever is pointed to by that VPC and post increment. Now, I don't know if BL lets us do indirect, and I don't know if it lets us do post increment, but it's indirect because we're not jumping to the addresses. We're jumping to something they point to. And then once you've done that, we're going to repeat, go back to the branch, to the BL, and call the next one. With the auto increment in there, it should be fine. Yeah, what else was I thinking might be missing? Well, I think we might have to be told where either where we are or where the header is or where the list of addresses is. We need to be told something. And we'll have to figure out how that gets there, so it knows where to start the VPC. I don't think it's going to start. I'm not sure. I'm really not sure. Yeah, it's going to be something like this. I'll be very surprised if there's not a branch linked and a repeat somehow. Okay, and so notice the exit condition of this routine quote. It's I don't know. I've heard it called an open subroutine. It's not. It doesn't return, and so it's just a little block of code, but it's the front half of a prologue, and then it's calling a bunch of things, but we always promise to put a link to N2D at the bottom. So eventually it calls link 2D, which restores the LR and VPC that got pushed. Okay. Well, now the meat of it, or that was the theory. Now the practice, I guess. Well, one thing is I'm questioning. So I don't know. I looked a little more at this and I can see there's issues. So one is this thing should be 8 bytes. So NL0. Now, I don't know if it takes 0 and then tries to do 4, 5, 6, 7, 8. That's one thing. But notice 8, but it's ASCII Z, so it's really 9. So it should not be 9 bytes. I also think the 4, 5, 6, 7 is trouble. And actually, I think we might be more clear to ourselves if we did ASCII and put the 0 explicitly. Okay, so since 4, 5, 6, 7 could be convincing it to write a octal number of some sort, I'm going to do dot. That's 1, 2, 3, 4, 5, 6, 7, 8. Okay, now we don't have to have we don't need a 0 byte at the end. We only need it at the end of the significant letters because we're going to use, we'll build a comparison that takes C strings. Okay. And, all right. So then we have this quad link to the previous entry. Well, this is the first one, so that's a 0. The link 2 steps away, which 16 bytes, because this is a quad. Oh, is this right? Well, dot is here. Dot plus 4 is here. Dot plus 8. I don't know. Let's see. Will the program list contain multiple copies of all routines? No, it's just going to contain the address of the routine. I'm not sure if it's pointing here or if it's pointing here. Okay, that's one of the things we got to work out. But but if it were calling NL, like, which is an assembly language routine, it would point to the start of where it says code. Okay, so the when I said compiler, really, like, whoever is pulling this in has to put this address, the address that's contained in here, in here. So this address is almost like a compile time thing. Well, except I'm not quite sure with the secondary. We'll have to. I maybe this is where it's pointing, but it is pointing to addresses, so it might be pointing here, and then use this to get that, or it's pointing here, and it uses this to get start 2D. I guess I should have put those arrows over here. Let me do that just to keep myself completely straight, because I suspect we'll be looking at this again. And then this is a link to N2D. Okay. Yeah, so this is just plain old addresses. Okay. Going back here. So I think this should be plus, well, plus 4 gets it here, plus 4 gets it here. Now, to me, this should be 4. I mean, if this is 8 bytes, this is 8, 8, 8. That should all be even because aligned. But I don't know if we might need a dot line in here as well. All right. See if I can remember how we're doing this. We're going to do, well, let's see if we're lucky in the right one. Unit test demo.out. Okay. Is that the one we were running for this? Oh, yeah. Let's remove star.o. Well, I guess we'll say make clean. Make sure that's doing what we want. Okay. And then we'll make it again. We were getting a compiler complaint last time. Oh, we still are. Okay. Yeah. Pointer not aligned. Here. At OX10. Okay. And so I ran across another tool called obj dump. They're both similar. Minus D. And we're looking at core.o. Yeah, the address of the code points to some, I think it's got to point to that address, starting address, and then that's why we do the branch indirect. Okay. Wow. I'm very puzzled. All right, I mean, this corresponds to our code. There's the store, LR is X30. Header, pound 16, okay. I'm not sure what that add X0. Oh, that's the pre-increment? I'm not sure. Okay. Oh, I'm looking at the wrong thing. No wonder I can't match it up. Okay, yeah. So string LR SP pound 916. Address, we want load NL character pound 16. I guess 16 is, well, okay, 0, let's start here. 0A A is 10, right, in decimal, and 10 is new line. So I'm pretty sure we've got a new line character and an empty byte, like we'd kind of expect. Yeah, well, I think the rule is that code has to be aligned to 16 bytes. Data doesn't, but if you start, I think if you access stuff that's not 16 byte aligned, it it may be slower and stuff like that. But I think you can do it in ARM 64. I'm pretty sure ARM 32 didn't allow it, or one of the earlier ARMs. You know, but so if this is off, that's fine. But like, what happened to 12, 14, 16, and 18 here? Right. Now this, okay, 2E, 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 2E. I'm sure that's a period. Did the error code point to 10? Yeah. It says pointer not aligned at OX10. Okay, 10. Well, the only pointer is this. Right? 18, and he points to 24. 0, 4, 8, 12, 16, 20. You would think that would be aligned by 4. Okay, so I think this 24 is saying well, it's saying the code starts here. That's not good. It doesn't seem right because the code starts here. All right, now I'm willing to bet this 2E, 2E, 2E is probably the decimal points, right? So 2 times 16 is 32 plus E is 1446. I'd have to look up my ASCII. Second quad pointer to code. Yeah, that's what I think. But okay, yeah. You know what? This 0 is probably, well, I want a 0 there. I'm not sure why it doesn't show zeros. But this one let's do the old classic. We don't know. Dead beef, hexadecimal. All right, let's do that again. Okay, there it is. Okay, so now I got a 0 after it. 6C, 6C. I think that must be NL and a 0. Okay, and then the dot. So I think the bytes are coming in this order. NL. So if this is L, C, M is D, N is E. So NL 0, period, 4 more periods, some 0 bytes. Oh, and this is where it's getting unaligned, right? As far as oh wait, these are hexadecimal. 16. Okay, so I'm a little confused. 0, 0, address 0 and 4 should be that first ASCII 8 bytes. Address 8 and 10, I would have thought should be, oh no, 8 and 8, what's 12? C? 8 and C, yeah, okay. 8 and C are the 0. 10 and 1014 are the dot plus 8. But I think maybe this is plus 4. Because we want it to point here. I don't know if that would align it. Okay, 2 times 16 is 32. How would this... Okay, that seems right. 32 bytes here to here. Okay. All right, let's try this. It's is pointing a little differently, maybe it'll be better. Save and make. Aha, we didn't get the warning. Okay. Yeah, yeah, it's NL in reverse. N, where'd it go? NL 0 dots addresses 8 and 0C are zeros that it doesn't show. I wish it would, but it doesn't. There's probably a flag. And then 18, 16, it's hexadecimal. 16 plus 8 is 24. Okay. And then dead beef is not a whole word. There are other words. Let's see. Words you can spell with hexadecimal. I just know lots of programmers use dead beef. Cafe babe, okay. Right. For Java. Dead beef, defaced. I'd like an 8-letter word. Or a 4-letter word. F to face, okay. 1, 2, 3, 4, 5. That's too long. Okay, well, I guess we can, I don't know, Cafe Babe is a little bit. Bed did. 1, 2, 3, 4, 5, 6. Oh, well, let's do. I guess that's okay. All right, let's see. So this. We did a remake. We didn't get a warning. Now we're trying to get. 20. Okay, now we're pointing here. Woof. Now, do I need this last quad? 1, 2, 3. Ugh. But, And then let's dump. Well, this will be longer, but unit test demo dot out. Okay. I want to see if it relocates, because if it doesn't, oh shoot, we're in trouble. Oh. This is 8:16. So okay, we'll try leaving it out and see what happens. But notice here we've got, well, there's our NL, but this value is still 20. It didn't get relocated. That's really too bad. Because now, like, we want it to be the address of this code, and now the address is blah, 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 3ED4, and we can't get to it. Okay, so we're going to try, well, okay, first experiment is let's leave this out and see if it screws up alignment. I think it does, because this is 8, 16, 24 is not even to this, but that's my theory. It's not so bad, because if we could extend our names and make them up to 16 bits. Yeah, that's a good question. Let's check the alignment first, and then we'll check the relocation. Okay, there's the not aligned. All right, so I think what we're going to do, okay, that's kind of filler. I 2, 3, 4, 5, 6, 7, 8. Okay. Name. Let's make it 16 bytes. And that. Okay, I'll make sure this works, and then we'll do the other. Okay. Oh, I guess the question was, did we get an error, alignment error? And warning, pointer not aligned. Am I clear? Pointer not aligned. Okay. Let's dump the code. Corrado. Right, he's unlabeled. That's fine. Okay, 28. Well, if I align, I think it's align 2 is 2 bytes. OX28. I feel like I need an align here. Are you talking about this 28? Yeah. Yeah, it is hex. It's the reference to the address, but it's wrong now because this alignment thing screwed it up or something. I mean, this is the new align, the dots, the ignored. I don't know if it is or not. It should be the ignored 8 character. It should be, 8 more bytes. Okay, and then a 0, two words of 0. So C plus 4 is C D E F 10. Okay, and then 8 bytes, and then 28 is the link, and it was only 28, so this is 0 byte. Oh, sorry, you're talking about line 18? I guess I'm not seeing OX. Oh, here. What is that? BL print. NL plus OX8. NL is at 20. What? That might be it might be like a fix-up address. Let's dump the out file, the binary. Unit test demo out, and we'll find NL. Okay. Yeah, so 13E8C, wherever that got off to, is print. Yeah, so I think that's it's probably a part of the linker process that it shows it sticks the address of the entry itself in that in that slot because it doesn't know what it is yet until it links everything else together. It's just linking to an external. Okay. Now we got the align to. All right. Let's make sure if this is going to give the message still. I'll make clean. I'll clear the screen, and then we'll do the make. So weird. All right, let's try the label. And I don't know if I feel like we tried this once and it didn't like it, but let's see. No, it's happy. All right. Now, dump the core.o. The label. Whoa. Is gone. Wow. Let's. I new assembler. I get answers, but current PC as relocatable. I'm not sure how. How about save current location data as relocatable? Usually there's a way to do it. I mean, in the assemblers I've used before that had this linking capability, I guess I used some that weren't. Yeah, I don't know. We'll try equals NL, but I have a feeling it won't matter. Okay. Yeah. Okay. Yeah, relocation records. I'm not sure why we don't see those. Okay, LD moves blocks of bytes to their runtime addresses. Yeah. That's a section. Assigning runtime addresses is relocation. Adjust mentions of object addresses. Yes. Okay. Can also generate other named sections. Yeah, we don't do that yet. To let LD know the data changes. AS also writes the object file details of the relocation. Most expressions as computes have this section relative new. It just deals with 4 kinds of sections. 1, 2, 3, 4, 5, 6. Okay. Yeah. How do I put a, let's see, GNU assembler? Put a label in a data field. Yeah, I don't think that's it. Some labels. No. Oh, that one sounds promising. A symbols, essential concept. Okay. Did I put a colon in mine? Yes. Symbol can be given an arbitrary value by equals. Oh, interesting. Okay. All local labels begin with L. Forgets them. Okay, yeah. CSA dot. Okay. Recurrent address defines meld contains address. Assigning it is the same as the org. Dot equals dot plus 4 is the same thing. Space 4. Right. Okay. Assigning a dot is treated as the same as an org. Okay. Let's see what the org. Well, okay. Yeah, that's an idea. I mean, we want. I mean, if we're going to have the header followed by the code, we can't really do that. Org sets the PC. Yeah. Oh. An undefined symbol, if it is 0, then the symbol is not defined. LD tries to determine the address from other files. You make this thing a symbol by mentioning a symbol name without defining it. A non-zero value represents a com. No. Dot type F. Yeah, I think that type thing is more for C++. Let's see. Type assembler directive GNU. associated with cough. Okay, well, that's good. Only within def and def records the integer int as the type attribute of a symbol table entry. Right. So I think that is really just for compilers that they can sort of force different types on things. And we had org. We got nothing there. I'm guessing we could do some sort of fix up um, in in the in the bigger picture. We're gonna we're gonna have some sort of interpreter that's responsible for pointing to the dictionary and um, providing the startup code for our system. I mean, I suppose we could go through the dictionary and find the fourth, third, fourth word in each thing. Ugh, that means our links are going to get screwed up too if we can't put that name in. Huh. I don't know how we're going to find this without it. Okay. What's weird to me is this notion of having a table of function names is very. I mean, I don't know that the C compiler, C++ compilers do it now, but it definitely used to be what they would do. Would be a table of function pointers. Huh. Well, let's do this for now. Let's make sure this is still hanging together. Pointer not aligned. Okay, I think the problem is it's referencing dot. Um, from a intermediate word. I bet if we swap these around, I don't think we can in the long run, but I'm guessing this will work. No. So it worked before. Okay, we didn't even have this before, and we restricted ourselves here, and we put quad dead beef. I think this works. Oh, sorry. No, it does not. What do we have that worked? Well, that's what I thought too. Yeah, you're right. It feels like it should. But yeah, maybe that's okay because 4 bytes puts it in the middle of something. Am I saving? Save this. Do this. obj dump minus d core dot o dot plus 8. Okay. Now it's going to be even further off. 1418. Okay, well there it does put it right next to it. It did complain though, didn't it? Okay, I'm going to put the dotted line back in. I think it is aligned to, because we were careful to make it, but maybe it can't tell that. Or maybe it doesn't, like it treats ASCII as an unknown alignment or something. Oh, sorry. Okay, I'm going to take this out and put this back in. The address at OX10 is OX18. 10, yeah, it should be OX18. I'm really at a loss. Okay, that's UDF 16 instead of 20. Okay, it's hexadecimal, right? So I got to add 6 plus 4 is decimal 20 plus, oh, wait, that's 1622 to 32. I got 10 bytes. That seems wrong, doesn't it? Like I thought, being it says dot, I think it would have said 14. So maybe dot is already moved forward. Okay, so 16 16789A is 4. BCDEFO. BCDEFO is 6. Well, that does sound unaligned. I'll give them that. But it's like we're line 10. It's a hex value. Yeah. Hex value 10. Oh, you're right. Oh. Okay, this is killing me back and forth. Okay, they're very consistent, right? They're putting OX in front of the ones that are not decimal. Okay, it's 10 itself. Okay, and we want it to be 20. Plus OX10. Well, plus 16. Okay, I don't know why I'm not. Maybe I'm just messing up the math too much. 8 points to 20, and now it's 20. Okay, so that seems right. Why dot is the start of this is 10 plus 8 plus 8. Okay. Or maybe it's plus 8 plus 8. So it's from itself to there. Okay. Yeah. I mean, it is right there. I just didn't grab it right in my mind. All right. So adding that seems like, why is that complaining? It seems like everything's aligned on, it's got to be aligned on 16-bit boundary. Sorry, 16 byte boundaries. Well, I mean, to me, this sure looks like 4 quad words. We got this of 8 characters and showing up as 8 characters. We got that 0. We got our 16. We got our dead beef. Yeah, what is the complaint again? I mean, it's like, can you give me more? That pointer not aligned at OX10. Now this is unaligned, right? Because it's, oh wait, no, it's 16. Decimal would be unaligned. 04 8C10. Okay, so that's on a 16 byte boundary. Like, what is your problem? Okay, I'm sticking a line up here. I did have a little slight theory that it might treat ASCII as like you're now at unknown alignment. But it's not, so I'm not sure why the linker would complain. But that's okay. Now, I don't know. We can. Whoa. Oh, whoops. Line 2. Now they got purple. Like, yeah. Pointer not aligned. Oh, man. I could have sworn we had this working at some point. Am I misremembering? I mean, and this thing looks aligned to me. The pointer is in 1014, and that's certainly divisible by 16 because it is 16. And then the value of it is 20, which is 2 times 16, so it's also divisible by 16. So I don't know what's not aligned. I guess, I mean, it's a warning. I don't have to pay attention to it. On the other hand, like this constant that does nothing, I don't see any advantage to having it here. I mean, maybe here, because if we do 16 bytes, 2 words, and then we have a link. So this is a 2-word boundary. This is a 2-word boundary. This used to be, and now it's not, but I ought to be able to build that table. So, okay, let's see, make sure it doesn't work before I go too crazy here. Yep. Get the warning, OX18, OX18. Now, I'm going to stick, is it a word? Forget my assembler directives. Octa? Octa is 16 bytes. Okay. Quad. I don't know if find word. Zero expressions. Well, don't do that. Okay. What about byte? I'm going to put byte, and it takes a list. Okay, I'm going to put 4 bytes in. 1, 2, 3, 4. Now this to me should make this unaligned. There's my 1, 2, 3, 4, and then this. And now this is not on a 16 byte boundary. It's off a step. Okay, so let me go back to, it worked when you added 8. Okay, we'll try this. We'll take this out. No. Yeah, it gives the wrong offset too, but 32, 20, 20. Is that weird or what? Oh, we moved out the dead beef thing. Okay. So yeah, deleting a word meant it was closer. And that actually makes sense. If it dot is really the same as the address of 1C or 1.8, dot plus 8, that's 24 plus 8 is 32, is 20. So it works, but it complains. I think. Oh, we still get that. 1.8. Well, I'm going to put another word in front just to see. Quad feed bead. Okay. Yeah, still get the warning. So it's, I don't know. I think we can ignore it. I don't know. We're going to have problems. I mean, we're definitely going to have to do some sort of fix up to make this dictionary work. Well, more than the dictionary. To make this local code pointer work, we're going to need that. Now, there was, let's try quad NL. It was like NL at page. Page off. I don't know. Will it even know what I'm talking about? Yeah. Expected relocatable expression. I don't know. I think we read this. Is the reference to an address program counter relative? As computes have this relative nature. Some expressions are symbol relative. Now that may be offset n into section. Well, that's kind of what we're seeing. Okay, I don't think that program would treat them as separate but equal. Okay. All right, and we don't have an include. Okay, assemble instructions. Okay, we can do plus and so on. Well, it sounds like this one does that the way we want. I thought it did too. I don't know. Oh dear. Okay, but that does make me wonder if we can, like from our fix-up point of view, can I name this? Dot? Oh, no, I wanted to use it like that. Because now it's not a forward address. Yeah. Where's that OBJ? It's 0. Okay. Undo. This seems right, other than the complaint. Okay, we spent an hour on it. I think we're going to proceed and recognize that we're just going to have to fix them up. I don't know why it thinks something's offset. Now, maybe when we start doing it, we'll find out. Yeah, it's offset. But I think what we're going to have to do, I don't know. My other, yeah, I mean, yeah. My other idea, like how am I going to know the front of a of a header of a, I don't know what you call these, of a primary? Like how am I going to recognize it if I'm trying to go back and fix it up, right? I mean, I can scan through, maybe I can put some starting point in, but Yeah, it's tricky without access to the symbol table, really. Okay, let's make sure this is at least consistent to something. It's got a warning. It puts what we expect. 8 bytes, 8 bytes, 8 bytes not shown, and then our pointer or our offset is really the way we should say it. Now, how's that going to work in our others? Well, they're going to reference a fixed address. Yeah, there must be a way to store addresses in memory. I agree. Relocatable. AVR dependent. I don't know if that's a assembly language. LM32. There's only those two. Store I think somebody's gonna bury both basic. Can we declare variables in the code section? Yes. No, that's not going to do it. X86. I said it was similar. I don't know if. Yeah. If a symbol or label holds an address, insert using a dc.a. Do we have that? Oh, good. I don't know if you can post a link or not. I don't remember seeing .dc anything. dc.a. Nice. Which is weird because we found this on a page. Huh. Okay. Oops. Document serves. I mean, that's kind of what I think we did. We did label plus a constant. Label ARC64 is what we're using. Okay, interesting, not in a quad. Well, I mean, it's nice that ARM thinks it should, the ARM folks should think it should work, but it should. I mean, I would have fully said if we used a label, it should be relocated. I could understand dot not not necessarily being relocatable. I mean, this is label minus dot is really a relocatable minus relocatable. Yeah, it's a difference. Don't think that's. Now line the start of the memory allocated. You must use one. Gosh, that's exactly what we want. um, string directives. ARM CLang. You would think that would be. I would think that's what we're working with. Okay, can I find words in here that I can say to make it? Yeah, and it can be all, even in the not in the same file. Okay, data definition directives. ARM label. I think this is the online version of the same bit. What does label.word? This is just an interrupt table. Yeah. Well, I think this is using the labels. Function pointer for IRQ, yeah. PC equals IRQ. Okay, that doesn't help. I don't know. TI sometimes has some relevant stuff, but I don't. Are they? Yeah, they're relative to ARM. This sounds like it's the same. I keep thinking something like this should trigger it. PC relative, PC relative, absolute. Well, in that sense, the equals. We didn't see any results from that absolute, though. Okay, let's do another quad. Equals NL. We got zeros. I remember doing this now. Yeah. Oh, it didn't even get put in? Oh, weird. No warning, no nothing. That's annoying. 1C. Did it not? This is so. I mean, I take this out. I've got 1 8 has 32, 20 has our code. Take this out. Rebuild. Redump. 18 has 32, 20 has our code. I don't know. Well, let's look at. Okay, minus O, minus arc. We don't need any of those. Force CPU subtype. I don't think we care. To treat as near any features for dynamic linking. I don't think we need that. So we're not. Fast. Now, we didn't get include to work. It might be worth trying that again. MySL saves the L's. We don't need that. Q. Default for ARM is already to use this one. It means system assembler. We don't care about branch prediction. Okay. I'm not sure how to move on. I guess what I'm trying to think is there a way to, do I have to have the header stuff right here with this, or could I somehow package it separately and then go through and build a table? But there's nothing that would tell me reliably where the code is, because at runtime you don't have the labels, so, and it clearly doesn't like to fill in uh, those labels correctly. I mean, the ARM CLang assembler seems like that's what we're using. Um, Maybe that's worth a question. ARM CLang assembler. ARM compiler. Okay, we're going to go through those. I don't know. I'm spending hours reading documentation was not how I envisioned this project going. All right. Yeah, we're going to go through them. Define macro. Position independent code. Not supported for IARC64. Okay. I don't know. Maybe there's a group out there that talks about this stuff. People that want to teach. ARM compilers that rely on LLVM like this. Oh, people are talking about. Okay. I can search. Um, relocatable. I don't know what MIR is. An address is a quad. It's a 64-bit address. Um, that gives us some funny stuff, really, but I think it's okay. I mean, what's funny is the instructions are are 32 bits. The addresses are 64. So there's a little discrepancy there, but it shouldn't matter to addressing that stuff. Um, well, what else could I search for? Code address. See, I think people are more talking about the LLVM as an intermediate language in here. But this kind of group would be promising. All right. Machine IR. I don't think that's the same. BB for basic block. Okay. Yeah, this is like that other thing. Our developer. ARM-C-Lang compiler. Assembler. Like, I really want to know where to get it, you know? Oh, for embedded. Okay, it really is not what we're after. Supports new syntax. Well, gosh, this one is the closest to giving a, if this is saying, I don't know, define constant address or something and it knows to relocate, I'm going to put this one over here. This is my query that didn't get anywhere. Okay. Debugging info. Sure. Well, it makes it sound like GNU assembler will do it. All right. Save that one. Well, okay, yeah, that's worth trying. We'll do that real quick here. So, um, we'll rebuild. Demo out. I think we looked at this once. All right, let's find NL. Okay, there's our, well, there's our stuff. NL 32. Okay. I'm going to ask a question. Does cough object file contain a table of labels? Oh, TI developed the cough. Okay. Yeah. Symbol table. Character name. Symbol value. Reserved number. Reserved storage class. Let's see about the offsets. The name. Symbol value is 4 bytes, 8, 9, 10, 11. Maybe that's it. Okay. Okay, so there is a way to dump that. All right, we're gonna take a break. I'm so disappointed. Oh, okay. Oh, it looks to me like your label NL being in here. I mean, either of these two to me ought to trigger this being relocated. NL in here in particular. I mean, it's a reference to a symbol that's defined either locally or globally. That just seems like a natural thing. Okay, shake it off. All right, no, 3 or 4 minutes. Welcome back. All right, I have one more experiment. What if we put an external symbol in here? Will we get anything different? Let's dump the object before we change that one. Okay. And do this. Do the make. 2 complaints about alignment. All zeros. Okay. I don't know. Okay. This. I'm trying to think of the ways around this. So, I mean, I think at one level, like the core of this is hi, here's an assembly language routine. You call it normally, it returns. It takes responsibility for the prologue and epilogue if it needs to. I mean, we want to do a bunch of those, 20 or 40. You know, it's not 1,000. Most of them are going to be pretty easy. And then we need to assemble those into a table. The code, I mean, there's no reason the code has to be right next to the pointer to the code if we can figure out a way to make that go. Now the ideas I have for that, one is that we somehow parse that symbol table. Let's see if obj dump can dump it. Probably T. Okay. Right. Here's your symbol table. Text ltemp0 is the start. NL is this one. Now, how to interpret that? Oh, 28 is the starting address here. Okay, so yeah, this tells us L is probably local and G is global, and L starts the label. Okay. Oh, and I referenced print, and it couldn't find it. Well, of course. I mean, it didn't put it in. Oh, well, maybe I should I didn't rebuild. Let's dump the the out. Uh, you know, I don't think it puts the symbol table in this without work. Oh, I'm wrong. Okay. Yeah. So one way would be we take this symbol table information. Oh, it's even relocated. Yeah. So we could parse this into what we need for our table, our header table. You know, we would probably have a list of names we want to include in it or something like that. Well, yeah, I wish we could add this address table. I mean, like, we need it. It's so annoying. But well, anyway, we if we given this that we can get from the object file as oh no, this is yeah, this is the one we need. Okay, so we would run the oh man, is this gonna work? Build the output file. Maybe build it as a library. No, we can't do that. All this stuff about relocatable. Um, well, what this would be like build this and then either patch our code. I don't know how to get this table in because I can't build it and then change it and expect it to be in the same locations, you know? Um, now we could put the data somewhere that our program picks it up and uses it, and maybe I don't know, that's pretty awkward. I hate to fight the assembler like this, but it's not impossible. And this is in the output file, and we saw the format of it, like it was 16 bytes for this and whatever. I think that's 2, 4, 6, 2, 3, 6, 7, 8, 3, 6, 8. Okay, so that's 16 bytes for the address. Does that seem right? I thought addresses were 8 bytes. Don't know. Okay. But it's 8 bytes. We know the global names, or we can restrict them somehow, and we got the name column. So we could say when you run this system, first thing you do is build the core header table, and you do that by reading this file. BL label offset times 12. Well, I don't know. We can't get that name in there, right? I mean, if we could get if we could get this relocated value I mean, we wanted to get that relocated value in that quad. Um, oh, I see. Okay. So, okay, that's an idea. Um, we can put print. That's a remote one. Okay. Let's try that. Okay. So let me put notes here. Right. So parse the object file symbol table used to build header table. That's another word. Code primary table. Build a primary table in code. Right. So we would keep information that says NL is at 0 and 4 is at 8 or 12. 12? Why 12? Isn't that they're 32 bits. Yeah, how did we get those? That's going to be interesting. All right, build a primary table in code. All right. Another idea is use a random value to mark head of tables. Okay. All right, so we've got a table in this one. Let's save this. Let's build it. Let's dump it. Okay, here's our unsub. Here's our table. BL. Now, how? Oh, I see what you're saying. Yes, yeah. BL. They are they have some number of bits for the address, but it looks like it's enough for what we need. So it can only call stuff within 4 megabytes or whatever. Okay, it's 12, 112, 14. Okay, so that's 20 bits. Okay, so 20 bits is 1 megabyte. If I'm doing my math right. To the 20th. Yeah, should be a megabyte. So yeah, if our core code got bigger than a megabyte, we'd be in trouble. But oh no, 114. Yeah, 20. Okay. Yeah, so as long as our code is under a megabyte, it fits. If it's not under a megabyte, I'm not sure how they patch that up. I don't know if they do it automatically or you have to go to do your own loads with that page add offset stuff and load it into a register and call through the register instead of calling an absolute address. But Yeah, this is a little promising that we can reference this, and then we would just mask off the 9.7 part, I guess. I'm not sure where you get 3EC4 out of 9.7 FFFFA. Like, I really don't get it. It's just 4 bytes per jump. 4 bytes is not a lot. Well, no, it can't be that. That's 32 bits. And it's a 32-bit instruction, so it's got to be a... Well, let's see if we can find the explanation. Maybe I should say ARM64 just to save myself. I had questions on this one anyway, so... Cond... Really? Oh, not available. Okay. .w... Well, we have a 32-bit instruction, so I don't know if we're getting an ARM64 or not. ARM 32 megabytes. You'll have restricted ranges from the address of the current instruction. Yeah, you can use it if label is out of range. Linker adds code to enable longer branches. Okay, so yeah, you can't really... I don't think there is. I think if it has an address, basically the linker will put it in a register for you. It'll add a couple extra instructions to put it in a register. Then you can branch to the register, I think. NG plus 8 sub C RTX. Well, ARM and thumb. BLX. Oh, RM contains an address to branch to. Changes the instruction set. Yikes. Okay. ARM. RM available. Okay, yeah, so I wanted to know... Oh, you can't use it as a table. Right, you'd have to know the starting point, right? I mean, let's go back to the code. So we clearly somehow from there they're getting this. I don't know how. This is only a slight difference, right? E7 versus E4. We'd have to find the bits on this thing. Well, here's branch test 2, 3F20. Golly. Like, how are you doing it? It must be shifted. Right, because the least significant, you can't branch to something at an odd address. So they may as well do one shift. You know, they may do a couple shifts to get a little extra out of it. But I don't see how you... Well, let's look at this as bits. I think I have a calculator here. Yeah. No. That? Okay. Hide binary. Oh, there's the binary. Yeah, I can't stretch this. Okay, lots of zeros. Well, maybe, oh, no, hex is useful. Yeah, like, I don't know how to get it. Okay, one more B. Oh, there's two more. Branch and exchange instruction set. Okay, that's not something we want. Branch and exchange Giselle state. BL. If there's no indirect jump, we're in bigger trouble than. Okay. Almost address. BX. Derives the target instruction from bit 0 RM. Does that mean it has to be an odd number register? An even number register, rather? Access BX condition. Can't move it to PC. Okay, fine. The PC used to be a register and it's not, or it used to be like one of the others. DCD. Okay. Not in there. Okay. Branch. They don't have BX in this list. That's discouraging. Branch. Well, they said they translated it. Okay. So there's no DCD. Oh, used to preserve a 32-bit word? Points to the stack. So it's kind of weird. I mean, people are seeing it. Miscellaneous instructions. Okay, this guy's been helpful for us. Huh? Okay. Well, 32-bit immediate in the instruction stream. Well, 32-bit won't help us. F310 load address to register using ADR. Yeah, so I mean, I'm pretty sure we can get an address into the PC. Let's look at the branch. BX. Okay, so he's got a reference for it. Good. Not so helpful. All right, let me take notes. Okay. Load address using ADR. And then I forget what our thing said. But this is, it's just a plain old branch. Did I let that? Not in this one, okay. No, I think there was something, didn't we just read something in here? Yeah. Okay. Okay, so that would force a jump. So we would have to manually save the link register ourselves or populate the link register. Not quite sure how we'd get that, but something. All right. Let's go back to this. A primary into code. Decode the addresses and add a base amount. Okay. Do I even dare go to the next stage? So I think we've laid out something. Oh, where's that? In F310? Okay, we're gonna have to find that one. Well, in the ARM docs. I don't think this one I have. Do I have a different one? Load an address without performing a data load. It's PC relative. Yeah, and I think you don't have to work out which encoding it is. You just have to conform to one. Jump table. DCD, do it. Well, let's see if DCD does something. Grr. Okay. That's like really annoying. So we can't use that DCD instruction that does the job. Okay, so they did that jump table, and then where do they reference it? ADR3 jump table, load address of jump table. R3, R0, LSL2. Yeah, so you don't need the bottom 2 bits, maybe? I know, it's so darn frustrating. And yeah, like I said, I really think Apple did not do right by us on this by not documenting their assembler and documenting, if they don't support these codes or whatever. It's and this jump table thing is just such an old. I mean, this technique has been around forever. I think the papers I had on threaded code and stuff were like in the early 70s, And jump tables have been no longer than that. Yeah, the Amiga had it. Actually, Commodore 64 had it too. There was a little vector of pointers to the routines, the ROM routines, and you could change that little table and point to a different routine instead of the ROM routine for something. Like, yeah, and it wasn't new in whatever, 80 whatever, 5, 6. It's doing it easier. I am puzzled by this. Let's see. Like, how do you get 1FC blah, 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 blah from our stuff? Oh, I know what I can do. Let's subtract. Minus. Well, let's get one we know is in there. Where's the table? Minus this. Okay, it doesn't ring any bells. Plus this equals. Okay, that's. Do I have a memory somewhere? Oh, come on, guys. Okay, how many how many bits do we get? It can't be 2. Well, let's find the other BLs. 979794. All zeros. Okay. Let's try. How about bit pattern for ARM64BL instruction? It's 24 bits, 32 megabytes. That's for a branch. Huh. Why did they do it that way? Oh, I see. Okay. Okay. So yeah, I think they're saying they're right shifted to um so you take whatever you get and then add 2 to it. So um well, let's take okay, let me put this in here just so I have it. Okay. Instruction equals that. Um label equals that. Okay, so in the calculator, let's put the label and then right shift it to for, okay. Can I copy? Come on. One, two, three, four, five, six, seven. 1, 2, 3, 4, 5, 6, 7, 8. Now I think the oh, right. That's why it keeps changing so much. Okay. So let's take this. But we can only, I don't know how many, we can't quite discover. They're saying you get 24 bits on a BL. Okay, so I think we got to convert this to binary and chop off, convert this as binary and only retain the first 24 bits. Okay. So that's 31. So that's 30. Okay. Minus, oh, they don't do parentheses. Oh, okay. Clear. Copy this. Paste here. Well, we know the highest bit is 31, so that must be the 4. So let's just take this, FB1. Okay. I put 2. I put 2 and then I put a 0 value. So I put new line, then print. Okay. And all right. So this is the 2 least, or we drop the highest bit, we drop the lowest 2 bits, and this is what's left. And so if we take the instruction 3EC4, I don't know, it's backwards, right? NL is right above it. Oh, well, we can decode that then, right? A, B, C, D, E, F. Yeah, 9/7's the BL. Oh, maybe it's just saying it's minus to it. Where's print? It's not far back. Okay. 97 is the BL. Okay, so let's take that out. Okay, let's take this. Negate bit. How about a bit flip? Does this do what I want? Twos. Complement, that's what I want. Nope, it isn't. FFFFA. Two's complement is not. Well, they're giving me 64 bits, I guess. This is not 64 bits. Two's complement, I think, is 6. Yeah, let's try that. 6, left shift 2 to get it back scaled. OX 6, left shift 6, left shift 2. I don't know. Sorry, I'll do it by hand. 6 is 0, 1, 4, 1, 2, no ones. Okay, left shift 2, put 2 zeros on it. 6 times 2 times 4 is 24. Okay, so I believe it's saying go back 24 bytes. Let's take this. Minus this equals 18. 16 plus 8, 24 bytes. Okay. Wow. Okay. So the BLs, everyone in the table is going to be shifted by 12 compared to the one before it. Or 12? It's going to be shifted by 8. Okay. Now I know what to do. Let's put 3 entries in, 2 of them the same, and then we'll see that they have different addresses, but they'll reference the same thing. Where is table? Okay. Yep. One's A, one's 9, because this one is four steps away. Is it 4 bytes? 2. 2 hex 2 is 2 times 2 is 4. This is 4 bytes further. Make sure this. Okay, let's do FFF9. Two's complement is 7. FFFA where's my clear? Two's complement is 6. So 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 7. Okay, so yeah, you'd have to know your own address, the address of the table, and then you subtract off four bytes is 32 bits, which is one instruction. So you subtract off 32 bits for each entry. So 32 off the first one, 64 off the second, and so on. Okay, so I believe you've solved it. I mean, it's um, it's got a little bit of weirdness. Okay, let's see if we can do one more. Okay, let's put test 1 in here and see some forward stuff. Make sure a theory, or oh, there's hello is closer. Well, even start. Okay. Oh, he's at 103 EEC. Okay, he's gonna be close. And I'll put them both in. Hello. Okay. And then I think we'll see positive values for those. Oh, well, there it is there. 3F20 is down here. And so this thing is all zeros on the front. The other one was F's because it was negative. Okay, so I think it's like mask out that 97, bring in a bunch of F's on the far left to get up to 64 bits, negate. Well, if it starts with F, yeah, I think if it starts with F, it'll negate in effect. I don't know if you have to negate. And then if it is with a 0 here, then it's positive. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is test 1. And print is back there. Okay. So yes, I think you can derive table from this stuff. You probably can. I mean, we can manually create these names that are going in and populate the headers from that, I think. Okay. This solves the table approach. And okay, so let me try and summarize. BL is PC relative. Mask off the 97 to get the distance to the label. If first remaining character is 0, it's forward. Otherwise, mask in leading FF. And go to complement backward. Okay, so create a table of BL routine. And then walk the table, finding the address, taking into account the increasing PC value of the table. Yes. Use the table plus an instruction position times 4. Yeah. Well, it sort of tells you how many words backwards to go. Yeah, but it's Okay. Okay. Yeah, I think I like this idea. It makes us do it at runtime, but we're walking through. I mean, I presume we can get the address of table, because we're going to do this in the code. I think the others. Well, I hope we can work out the way to get the addresses of the other stuff at the in the secondaries. Okay, so I think this convinces me this can be a solved problem for us. So let's do that. Okay, and these can be numbered. And this is all approach 2. Okay. Good. All right. Well, it was painful to solve this problem. It's kind of ridiculous we have to, because it would have been real nice to have a relocatable label name that actually got relocated, like every assembler that does relocation that I've ever seen. It may exist. Apple may know it, but they didn't put it anywhere we can find it. And we've done a ridiculous amount of searching for this stuff, and nothing is coming. We're not getting anything from Apple documentation, right? We're either getting ARM or GNU. That's the breaks. Okay. Next week, I'll be back at the usual time, 2 to 4:30 Eastern, 7 to 9:30 p.m. UTC. I feel like this problem is theoretically solved. I think it might be time to try our hand at a secondary and put. No, you know what I think I want to do is let's implement a little bit of stack stuff, and then we will have to address some things. We'll have to figure out where the stack's gonna our data stack, the stack that our language will use. There's also the return stack that the system provides, but we'll need a data stack for this Forth-like language, and we haven't done that yet. So I think what we'll do is we'll implement a primitive or two that uses the stack, and once we have those, I think we'll tackle the secondaries. I'm I'm hoping we can just request a big blob of space for the stack and get that, use that as, get a data reference to it. It should be in the data section. So we'll have to use that long loading expression, but we may have to do the page offset stuff, I guess is what I'm saying. But I think we can implement a couple of those and then try our hand at some secondaries and see if we can get that together. If we can do that on Monday, I'll be really happy. It may be a little too much, but once we get the secondary method like that, then write that the two routines that I talked about here, a start 2D and an end 2D, and see if we can plug them in a way to run our secondary using start 2D, end 2D. I think we can TDD the primitives, and I think we can TDD this. We'll see. All right. Well, Mudshark, as usual, thank you so much for your help and advice. And others, hope I see you as well sometime. Take care. Bye bye.